Hello, and welcome to this Rittal Corporation webinar. Now allow me to introduce today's speaker and get this webinar started. John Carnevale is Rittal Corporation's Marketing Manager for the food and beverage industry. And with that, I'll hand things over to John. John?
Thank you, Kim, and thank you all for your time today. I sincerely hope that you learned something new today and come away with a better understanding of enclosures and food processing. The enclosures that we're talking about today are the ones that house your electrical controls that control your food processing equipment and processes. Sometimes you would refer to them as your control panels. So we're going to talk today about hygienic design best practices and how they will benefit you in your food production facility. So here's the agenda or the topics that we're going to be talking about today. We'll be talking about hygienic design enclosures that are used in the food and beverage industry. We'll do an overview of a production facility to level set us all on the actual environment and application that we're talking about. We'll talk a little bit about food processing equipment standards and other relevant organizations. We'll talk about the challenges in the industry and why we need sanitary design practices or hygienic design practices. I'm also going to talk about the 10 principles of sanitary design. And then I want to review with you our Rittal hygienic design enclosure system. And if we have time at the end, just a brief history and overview of the Rittal Corporation. So what I want you to come away with today are basically these 3 points, that hygienic design enclosures can improve your overall sanitary conditions of your production lines, your process equipment, your entire facility. They could reduce the amount of time and cost for cleaning, sanitizing your equipment, and also reduce the amount of time that you're in maintenance and repair of some of that equipment due to water damage and water ingress into those enclosures. So the food factory is a unique place. It's a very difficult environment to operate with. We're handling food safely is always an increasing challenge. Trying to meet production output requirements, meeting the high demand of production and handling the food at the same time becomes an increasing challenge. Ensuring our machinery and equipment is properly cleaned so it clears inspections and bacteria doesn't grow on our equipment. We need to ensure good manufacturing practices. We have customers, government organizations that will come in, inspect our facilities, and we need to make sure that we're using good practices. We may have different safety zones within our facility. So we may have created food safety zones where traveling between different zones with people and equipment and materials traveling through those zones has different requirements and different regulations to follow. And then, of course, there's always a danger of food contamination, lots of different bacteria like Listeria and others that could, get people sick, and obviously something we want to avoid. And then always meeting regulations, whether it's the FDA, the latest Food Safety Modernization Act, or USDA standards, or other government regulations. So a very unique environment to operate in. Let's take a look at a generic overview of a typical food and beverage factory. So you may have different zones within your factory. In a non-hygienic zone or non-sanitary zone, the machines don't have contact with the food. This may be where maybe you're packaging, end-of-line packaging, crating, palletizing, where your machines and your typical enclosures are using the typical requirements like NEMA type, UL, NEC type requirements. In a hygienic zone, in this zone, machines may have contact with the food. They may require stringent washdown and cleanability requirements. And so those enclosures will have additional requirements. You may be looking for a NEMA 4X. You may be looking for IP66 for, to resist water ingress. The IP69K, that's the hardest washdown requirement rating you could get. You may have requirements for slope tops and things like that. But there is also other standards that come into play for food processing equipment. So in this next slide, I have 5 organizations listed here. And well, they have food processing equipment standards, basically. What I did, you could see the 5 different organizations. The bullet points below, I basically cut and pasted what their mission statement or what they said on their website, what they do. And they all basically are there to protect consumers, to help food and beverage manufacturers and OEMs of processing equipment to develop better sanitary designs in their equipment to help protect consumers. So the first one, the NSF International, originally the National Sanitation Foundation, is one. The 3A Sanitary Standards is another organization, and both of these have food processing equipment standards for hygienic design of equipment, sanitary design of equipment, food, beverage, and also pharma industries. And we're going to review one of their standards. That's the one I have highlighted in red. That's the NSF ANSI 3A standard. That standard is available on Global Spec. I recommend you guys get that standard and understand what it says in there. We're going to cover a lot of some of the important things that as they apply to enclosures, and we'll talk about that standard quite a bit. We're also going to talk about the 10 principles of sanitary design that comes from the North American Meat Institute. You may be dealing with equipment that comes from Europe or making equipment that goes to Europe, and you may have heard of the EHEG. This is the European Hygienic Engineering and Design Group. They're basically the equivalent to the 3A organization here in the U.S., and they basically have synergistic standards. They've gotten together and created a lot of the same standards, and a lot of them standards are based in the 10 principles of sanitary design. So we're going to cover a lot of the standards and those principles in the next few slides. And then you have the FDA, the U.S. Food and Drug Administration. You've probably heard, if you're a food and beverage manufacturer, you've probably heard of the FSMA, Food Safety Modernization Act 2011, where a lot of those rules and regulations are coming due now. You may be in the middle of, if you're a food and bev manufacturer, you may be involved with a hazard analysis and critical control point process where you're identifying hazards in your facility, on your machines, and your processes. And what you're going to see is that enclosures could be part of that analysis, and they could be hazard areas that you need to look out for and possibly incorporate into any of your programs that you have in your facilities to look at hazards. Talking a little bit more about hygienic zones, or they may be called sanitary zones. The NSF 3A standard has a couple of definitions. They define product contact zone, and they define non-product contact zone. So basically, right, you may have various zones within your facility where the raw material comes in one end. You may have that's your highest sanitary condition zone. Then you may be in your processing area. That could be another zone. And then at the end where your packaging could possibly be another zone. So this is not a set rule here. This is up to the user to define the zones in their facility and what's right for them. But in these two definitions, basically, product contact zone is defined as equipment that's coming in contact with the food. It's touching the food. It's working the food. This equipment has frequent wash down and sanitation requirements. This is where you want to use hygienic design enclosures. In the non-product contact zone, this could be packaging equipment, equipment that doesn't require frequent wash downs or even milder cleaning methods, maybe just wiping down. You may also require stainless steel enclosures in an area like that due to humidity and other things. So just to be aware that this is something you could do in your facility, or if you're working inside one of these facilities, to be aware of the different zones and as you travel throughout the different zones. It's a harsh environment for machines, right? Things that are happening, you have daily cleaning of some machines. You may be using high pressure, high temperature, aggressive cleaning agents. You may have wide temperature fluctuations, meaning maybe you're in a meat production plant where the temperature is like 34 degrees, and then you clean that equipment with hot water, 140-degree water, and so you have different temperature fluctuations. Creates condensation and things like that. You may have frequent maintenance due to the wash down process, and In surveys after surveys, we see that people have maintenance issues after washdown, and we'll talk a little bit more about that. And you're always trying to ensure sanitary conditions and passing inspections after the cleaning. So harsh, difficult environment in which to operate. That's why you'll see our hygienic design enclosures will solve some of these problems. So why do we need hygienic design? So the first problem is we have water getting inside the enclosures. Okay, so what you're going to see in later slides is that some of the designs of enclosures create a large gap between the door and the body of the enclosure, and it's hard to clean back there. And typically, a cleaning crew will have to, get close with the high-pressure water in order to flush out contaminants. And the high-pressure, high-temperature water has the potential of damaging the polyurethane foam gaskets. Okay, and then once water gets in, obviously we know what happens with the electronics, shorting things out, causing damage, possibly even creating a safety hazard. So that polyurethane foam, it could possibly absorb, it absorbs humidity, liquids, detergents over time, and reduces the service life. It's difficult to exchange. Not that it cannot be exchanged, but it's difficult to scrape off that gasket and replace it. It can be done. Some folks will just replace the door, but you see, all the extra work that needs to be done to replace that gasket. Okay, and then the coloring of the gasket, you may have bits and pieces come off that, and you won't be able to distinguish that. It may look like seasoning or some other things in the food. So another hazard there with regard to the polyurethane foam coming off of the door of the enclosure. So we know water and electricity don't mix. And so in this survey that was conducted by the Cole Morgan Advisory Council, Cole Morgan manufactures high-quality motors and drives for the food and beverage industry. And in one of the questions that they asked is how often do machine components fail due to washdown sanitation cycle. And so 86% responded that they had failures of one type or another in their equipment. And so, a lot of things happen when water gets into equipment, especially control panels, causes damage. You could see some of the things that may happen. Okay, we might lose production, or we may miss commitments. Different things are happening, costing us more money. The worst case scenario, right, we may have some product contamination. And in the next slide, I'll show you how, basically. So our second big problem is contamination and bacteria growth. Okay, so the problem here is, if we're getting up close with our power washers to clean the behind the flanges, we may be driving food contaminants, food particles into that enclosure where bacteria may start to grow. And then the other thing is we have controls on that enclosure, right? HMIs, push buttons, things like that, where operators are touching, and then maybe they go and touch other equipment, other machines, and creating cross-contamination. So, you can see the statistics put out by the CDC. 3,000 people die each year from foodborne diseases. So if there's any possibility that we could help with that in using sanitary design and hygienic design practices, definitely help reduce the possibility of contamination. So in this next section, I'm going to review the hygienic design enclosures. And at the same time, I'm reviewing the 10 principles of sanitary design, which you'll see that is in red text. And then we're going to review some of the standards at the same time. So kind of all doing this together from slide to slide. And the NSF 3A standard is in blue. First of all, let me just tell you where the 10 principles of sanitary design came from. They came from the American Meat Institute that was founded in Chicago in 1906. So you could imagine as the food industry started to flourish, the federal government stepped in to create some laws, as people were starting to get sick and contamination was happening. And then other organizations started to form, like the American Meat Institute. In 2001, they put together an equipment design task force, because there are still issues within the industry, especially in meat processing plants. So this equipment design task force came up with the 10 principles of sanitary design, which are now used in almost all the different standards that you'll read for processing equipment. the North American Meat Institute. So that basically was formed by the merger of the AMI and other meat, the North American Meat Association, now known as NAMI. So the enclosures that we're going to be talking about are basically these wall mount and terminal boxes. They come in lots of different sizes. They're perfect for the washdown, areas, for your process controls, machine controls. They have all the right certifications. You could see UL listed, type 4, NEMA 4X, IP66 as well, and then IP69K as well. We're going to talk a little bit about IP69K later. That's the hardest water test to pass, and we'll talk a little bit about that as well. So these are the what I'll be talking about in the next few slides. So looking at sanitary equipment design principle 1, it says cleanable to a microbiological level. So the equipment needs to be able to be cleaned. You need to be able to take it apart. It should be designed, to prevent any bacterial growth, bacterial ingress, on or around the product, on the contact surfaces. So Rittal hygienic design, we use stainless steel. It's brushed very smooth, 400 brush grain. It has a very smooth surface with a peak to valley surface roughness of less than 0.8 micrometers. So you could see that meets, down below the requirement in the standard talks about having 0.81 micrometers. So we meet that. So the point is smooth surfaces. When the surfaces are smooth, it's less likely for bacteria to stick to it and grow on the surface. So smooth surfaces are also easier to clean. Our internal hinges don't trap the debris. There's nothing exposed, no hinges exposed that could trap any food stuff. The blue silicone gasket will keep the food and beverages from getting inside the enclosure, and things from getting stuck behind the door flange that you cannot see. That blue silicone gasket resists the cleaning and sanitizing chemicals used, and it's compliant with the FDA regulation that's called out for reusable gaskets and things like that. So focusing on that blue gasket, what is it doing for us? So it's basically creating a tight fit all the way around between the door and the enclosure bodies, fitting all the gaps and creating a watertight fit. Okay, so nothing gets inside of it. So it has a smooth finish where water and debris could run off of it. It's dyed blue, so it's distinguishable between anything that, if any pieces get chipped off of it, any mechanical damage to it, you'll be able to see that blue material. It's removable and replaceable in minutes. You could pull it off and replace it. They're very durable. They stand up to the cleaning agents and sanitizing agents. We've had these enclosures out in the market for a long time with no problems. If they need to be replaced, it's due to mechanical damage typically, or operator error, or they've caused some damage to it. It's not toxic, non-porous, and non-absorbent. And so take a look at the diagrams below, where I'm looking at 3 different enclosures. This is looking down at the front corner of the enclosure where the door meets the flange of the body. And you could see the polyurethane foam, the hatch pattern. That's where the gasket comes in contact with the body of the enclosure. And you could see in some of the designs that are out there, if food stuff has been flushed down into that gap, it's be a dead space where things will get stuck. It's hard to clean. Very little chance of things getting out in between that gap. In our Rittal IEEE line, our wall mount enclosures, we have a larger gap where you could see in the angle of the flange. This helps flushing contaminants out if they are to get trapped in there. Having a little bigger gap will help flush things out, but it's still difficult to clean back there. And then you could see in the third diagram on the right where the blue gasket actually fills that gap, so there's no gap there, and it's much easier to clean and nothing is getting in behind that flange. And you could see what it does in that bottom picture where it actually creates that seal where nothing is going to get inside of there. So what are food processors looking for? Okay, they're looking for cleanability. So in this This survey that was done by the PMMI organization, Packaging Machinery Manufacturers Institute, they did a survey, and 73% of the food processors came back that they want equipment that's easier to clean. We want it easily to disassemble, easy to clean, easy to inspect, easily put back together so we can get back to production. So very important for food processors. So here are some of the designs that are on the market today. And we know that products that meet minimum requirements aren't always the best design. And so in this case, there's a big gap in between the body and the door of the enclosure, and stuff could get trapped in there. Things get trapped. It's hard to clean. It's hard to inspect. And you can see what it says in the standard. The surfaces shall be cleanable and easily accessible for cleaning and inspection. So is it cleanable and inspectable? I'll answer those questions in the next couple slides. And then you can see some of the dead spaces back there where food and things could get trapped. And we'll show examples of things getting trapped there as well. Some of the other standards talk about exterior flanges being sloped in a way to drain away from the openings. That's fine for liquids, but solids and foodstuffs that get lodged down in there aren't going to drain away unless they're flushed away with high pressure water. And all covers should be sloped to an outside edge. So the standard says no dead spaces. So in some designs, there are dead spaces behind the door flange, as you can see. That's places where things could get trapped or retained. And so if I look at the picture on the right, you could see in this enclosure, you could see the installation of this enclosure. They did a great job welding the spacer on the back of the enclosure. When they went ahead and mounted the enclosure, they created some dead spaces here where food could get trapped, and it's very difficult to clean. They have exposed threads, which is another part of the standard where you don't want exposed threads where bacteria could grow and things could get trapped on those threads. Here's another design. So in Section 5 of that standard, design and construction, they talk about openings and covers. And so we're basically talking about panels and covers. They should be designed to avoid any adverse influence, so entry or accumulation of soil. So piano hinges like this one are notorious for trapping food particles. The clasps that are used to hold them closed are another location where food stuff could be trapped. So these are not typically the design you'd want to use in washdown environments where food and things will be trapped and bacteria could grow. So, the answer to the question, cleanable, inspectable, yes, everything could be cleaned and inspected, but with what effort level? With much higher effort, much higher training and risk, of course. So you have higher operational costs, potential hazards. The other thing to think about is do the enclosures need to be open for inspection? Do you need to have a trained electrician open that enclosure for the cleaning crew to clean it? Potentially you'll be, if you have to open it to inspect it after the cleaning crews have left the building, you may be doing some additional cleaning behind that flange. And then the other problem is with these clasps. I've talked to many maintenance managers who will tell you that sometimes the operators will not fasten all of them. There's actually 6 clasps that go all around this enclosure. Sometimes they only secure a couple of the clasps, and they don't tighten them all down, and then the cleaning crew comes in, and water starts to get in that enclosure because it's not completely sealed. So a couple more things about why we need hygienic design. So here's an experiment that we did. We took one of our hygienic design enclosures, which is in the picture there, and we coated it with a milk product. Milk products obviously grow bacteria quickly, and we marked it with a fluorescent substance so it would glow under a black light. So we went ahead and cleaned that enclosure and then allowed it to dry, and then we put it under the black light, the fluorescent light, to see what we could find. I'm going to show you the results in the next slide. Just first, I want to direct your attention to the IP69 standard for washdown requirements. To pass that test, you could see the water pressure that's used, the water temperature, and the nozzle distance. So you got high pressure, high temperature, getting up very close to that enclosure. When we test our enclosures, you could see we elevate everything, so we know that we're passing the test. We go to higher pressure, higher temperature, and how close, very close, and that goes all the way around that enclosure. So that's a very difficult water test to pass. It's tougher than an NEMA 4X hose-directed water test. And so the results of this test you'll see in this slide. On the top is one of our regular wall mount enclosures, and on the bottom is a hygienic design. So you could see, after the washdown process, you could see where the stuff is getting stuck in the hinges, in the top area between the flange and the gasket, the door locks. Any little crevices where water is going to get trapped or water is going to pool or accumulate, this is where the bacteria is going to grow. Threads on glands, threads on leveling feet. Okay, so then you can see on the bottom our hygienic design, completely clean. All surfaces are designed to shed water and reduce bacteria growth. So equipment design principle number 2. So made of compatible materials. So they're talking about what kind of materials you use to construct your equipment. It should be compatible with the product, the environment, cleaning and sanitizing chemicals, and the methods for cleaning and sanitation. So some of our design features, we use 304 stainless steel. They call out 300 series steel. So we meet that requirement. The silicone rubber gaskets conform to that FDA guideline that's called out in the standard for gaskets and O-rings. So meeting all the requirements for materials, stainless steel and the rubber gaskets. Sanitary design, equipment design principle number 3, accessible for inspection, maintenance, cleaning, and sanitation. So we want to be able to disassemble that equipment, clean it, and inspect it for maintenance and cleaning. So what kind of things do we build into our enclosure? We've got the sloped roof. So you can inspect to make sure nothing's on top of that it's cleaned, and you could do it from a distance. We have a large gap between the overhanging roof and the door for easy inspection, so you could see that there's nothing trapped in between. The blue gasket's highly visible from a short distance, so you can see that it's clean. The overhang of the roof allows water and food stuff to drain off the enclosure and not be deposited in between the door and the enclosure body. Sanitary design, equipment design principle number 4, no product or liquid collection. So like we've been saying, you want the liquids to be self-draining. So any liquids that need to drain off the equipment because they could harbor and promote bacterial growth. So again, some of the same features, the sloping roofs, the tapered doors, inclined surfaces. Every surface has a slant or incline to have water shed off and drain off without any additional effort, even the key locks. So everything's been thought of, so nothing pools, nothing accumulates on the enclosure. So I combined 2 principles here: hollow areas be hermetically sealed. So that really applies to frames and rollers and things like that, not so much the enclosure. But it talks about anything that may be attached to that, bolts, studs, mounting plates, and things like that. Need to have continuous welds and in a smooth surface as well. And then the other number 6 is no niches. So we don't want any pits or cracks, any corrosion, recesses, all those different things where food stuff could get trapped and bacteria could grow. So again, smooth surface on the enclosure, very smooth, peak to valley roughness, no external attachments with fasteners, so you don't have any protruding, rivets or bolts or anything like that. No unnecessary holes in the enclosures. So surface texture, they talk about free of imperfections of pits, folds, and cracks. So very important to have smooth surfaces, obviously. Principle design number 7, sanitary operational performance. So during the operation of the equipment, you want it to be sanitary conditions, meaning you're not trapping any loose food, trapping any, creating conditions where bacteria could grow. Bacteria grows very quickly. So our blue gasket, keeps obviously things out of the enclosure during the normal operation and while the equipment's being run, keeps things from getting trapped. Also during the washdown process, keeps water from obviously getting inside and driving contaminants inside the enclosure. Sanitary equipment design principle number 8 talks about the maintenance of enclosures themselves. So it talks about human-machine interfaces, HMIs. You got push buttons, all kinds of different controls, maybe touch screens and things to control the machine or the operator to get information. And so the guys are touching those. They could be spreading, food stuff around the facility. So things that keep those areas clean. We have a few different products. You could see you could cover the HMIs. You could cover your buttons with viewing windows or flaps like we have on the right. You could enclose your computer screens, your printers, your computers in our command panels there, the picture in the middle. You could protect your keyboards with our keyboard supports. So again, protecting things during the washdown, making sure that they're protected, and also at the same time keeping things clean and reducing the spread of contamination and bacteria. Principle number 9, hygienically compatible with the other plant systems. So basically they say equipment design must ensure hygienic compatibility with other equipment systems such as electrical, hydraulic, steam, air, and water. So I related this one to our accessories as being compatible with the plant systems. So there's requirements on mounting the enclosures. If you're going to mount it to the wall, it needs to have a 2-inch space off the wall so you could clean behind it. We have wall spacers, hygienic design wall spacers, designed to shed water. Again, leveling feet we talked about. You need to keep the enclosures off the floor so you could clean underneath underneath those enclosures. And then cable glands, special cable glands they don't have any exposed threads. They don't trap anything. Smooth surfaces so water runs off of it, and they are easy to clean. Okay, and then you could see in Section 5 there of that NSF 3A standard, they also talk about the same thing about the supports off the wall, the feet off the floor, those type of requirements. All right, principle number 10. Validating cleaning and sanitizing protocols. So basically what this is saying is, you should have directions. The manufacturer of the equipment should have directions on how to clean it, how to disassemble it, how to put it back together, how to keep the thing clean, what kind of stuff to use to clean it. And so, pretty straightforward with the enclosures. It's stainless steel, typical cleaning requirements for stainless steel. It's resistant to the chemicals used in the cleaning process and resistant to to corrosion as well. That's the 10 principles. We talked about how this could save you time. So if it reduces the amount of time to clean, potentially saving, a couple of minutes a day or a couple of minutes in the process for each enclosure. So we estimated if you could save you, the short amount of time, 5 to 6 minutes, the cleaning time in each enclosure, that adds up throughout the year. This is, one line. You maybe have multiple production lines, many machines. So if it's easier to clean, you're going to save time. You're going to save water, maybe even save cleaning agents and stuff like that. So, and that's just the cleaning part. We mentioned inspecting an enclosure. There's no need to open the enclosure to see if it's clean. There's no gaps, so nothing's getting trapped. Conservatively, I'm saying you could save 1 to 2 minutes, but there's issues that could realistic things that could happen is you have to have a technician or a trained electrician to come in to open that door, to inspect it, to make sure it's clean behind the flanges, and then, like I said, there might be some additional cleaning. And if there's any additional cleaning, chances are the cleaning crew has already moved on, or possibly you're going to fail an inspection. So potential here, again, for saving time in the cleaning and inspection process. So just another illustration of what hygienic design accessories and design practices will do for you. So, end users are doing all they can to make sure they have sanitary conditions. OEMs and machine builders need to do the same as well. Building equipment that's easy to clean, easy to keep sanitized, and easy to be disassembled and put back together. A couple of the other products that we have hygienic design related is our hygienic design large system enclosures. If you need something bigger than our wall mounts, we do have this available. This has sloped roofs. It's got a blue silicone gasket to keep out the water and debris. Internal hinges. We have 4 different sizes. One's a double door that you're looking at in the picture, and we've got 3 modular sizes, meaning you could put as many of them together as you want. Right now, we do have these approvals. We have an IP66 and an IP69K. That I mentioned, the IP69K is a much tougher water test to pass. And then we also have the UL NEMA 4X rating coming first quarter next year. We've already passed all the water tests and a couple other tests that need to pass to get that classification. So another option available. A couple of ways to install some of these large system enclosures. On the left, here's a customer that mounted them on a mezzanine up above the equipment, and so they could clean underneath it. They could clean the cable racks and things underneath it pretty easily. The next picture is showing the glands mounted on the side of the enclosure, if at all possible. I know it's not always possible to do that, but then they're visible, they're easier to clean, and you can inspect them much easier. If you have to go underneath, then of course, it's much more difficult to clean, but so you got to make sure that you put them on leveling feet so you can get underneath them and clean them. The picture on the right is just another way to mount our larger sizes of the wall mount. If you want to lean them up against the wall, you can mount them on the wall, put some mounting feet underneath it and do this as well. Or you could lean it up against the machine, attach it to a machine in the same way. So different ways you could, just some more guidance here on mounting the enclosures. We have some hygienic design climate control products. This hygienic design air to water heat exchanger is brand new this year. This is a great alternative to air conditioning units and fan units in an application where you have lots of dust and powder, maybe flour in a bakery, or maybe you're doing making candy and you got powdered sugars, or whatever ingredients that you're mixing that's powdered and it's getting into the air, and your fans and air conditioning units are pulling them in, and you're cleaning your filters all the time and it's getting clogged up. This is an alternative, especially if you have chilled water in your facility. So you could see we have 2 versions. One's mounted to the compact enclosure on the left. The yellow version is mounted to the large enclosure on the right. It's got the blue silicone gasket, so when you mount it to the enclosure, it seals, and no foodstuffs could get trapped in between. And our water inlet and outlet are hygienic design as well, designed to shed water and no exposed threads. We have a hose-proof fan hood. That's the pictures on the right. This will maintain your NEMA 4X rating on your enclosure. It's got the blue gasket, again, that will seal out any food stuff from getting trapped in between. And there's multiple sizes for multiple different size fans. Covers your fan, and just a good alternative to protect any water ingress through that fan. A couple other applications. We do make a fire extinguisher cabinet, and as OSHA says that we need to have a fire extinguisher every 75 feet, so you may have some fire extinguishers in your washdown area where your food production area is, so you don't want to have to clean the things you don't want to clean, right? So that fire extinguisher could be getting splashed with food and things, and then it's difficult to clean. So we have a fire extinguisher cabinet specifically for that. It's got a T-handle, so there's anybody could get inside of it. There's no lock, so meets all the requirements. We see different applications for our wall mounts. We had a guy that using the wall mount for his tablets. The tablets that controlled his lines. Status monitoring of his production line, controls. So what he wanted to do is leave it near the production line during the washdown process, and it was protected, and then it would be available for the next shift and in the right place. So different ways you could use it, not just for controls. You need anything to protect around in that washdown zone. It's a good cabinet to store things as well. So just more applications, more ideas to use. All right, so that's all about the sanitary design practices and hygienic design enclosures. Just a real quick couple of tidbits about Rittal. Rittal is the world's largest manufacturer of industrial enclosures, enclosure systems, and enclosure accessories. We're headquartered in Germany. We're founded in 1961 by Rudolf Loh, and we're operating 65 subsidiaries in 78 countries. 15 international manufacturing facilities, making up 4.32 million square feet of manufacturing facilities. We have over 11,000 employees. We're privately held by the Freedom Low Group, which is a conglomerate of many companies that are there that help support one another. We've been growing steadily, progressive growth. We have over 15,000 products in our system. Freedom Low Group is comprised of 15 different companies. The ones that you may recognize is the Rittal International. That's where Rittal Enclosures is. So we have Enclosures. We also have ePlan, which is our enclosure design software, and it does many other things than that, but kind of creating a package where you could design your enclosure, build your enclosure. We have enclosure building automation equipment, stuff that will tap your holes, put your cutouts in for push buttons and HMIs, all automated process, all of enclosure automation process of designing, building, and the whole 9 yards to help you there. And then those other companies are like we have a steel company, a plastics company, all providing the raw materials and things for Rittal, and then support services. So we do make stuff here in the U.S. Our U.S. headquarters is located in Schaumburg. That's where I'm located. We have a manufacturing facility in Urbana, Ohio, just outside of Columbus, where we make most of our stuff for the U.S. market. And then we also have distribution there in Urbana. We have distribution in Houston and also in Nevada to help supply your needs all over the country. We have over a 500,000 square foot manufacturing facility here in Urbana. It's been founded in 1982, and it's a very highly automated manufacturing facility and also highly automated warehouse. So it's there. It's also got a training facility, and it's also got one of the longest paint conveyor lines in the world that provides the best painting of all of our enclosures, multi-stage process. So very highly sophisticated facility to build our enclosures right here in the U.S. So I've got just too many things to talk about, to go through, but we've got enclosures of all kinds, wall mounts, freestanding, floor standing, HMIs, consoles, every type of enclosure that you could imagine, in addition to climate control, air conditioning units, heat exchangers, all the different things that go along with your enclosures, accessories, etc., even IT enclosures and cabinets. So full range of enclosure options. Okay, so that's the presentation. We do have time for questions now, and I'm going to go to our chat box here and see what questions we have. Okay. Okay, let's see. Got a question here from Juan. Hello, what does HMI stand for? HMI stands for human-machine interface. So on the enclosures, we'll have some HMIs that are there to control and monitor the equipment. So that stands for human-machine interface. Let's see. Question here from Jeff. How much more common are requests for IP69K versus IP66 lately? That's a good question. We don't see a lot of specs that call out IP69K specifically. It's either NEMA 4X or IP66 typically. But we do want to draw your attention to IP69K because it is the hardest test to pass if you are putting enclosures into the washdown zone. Okay. Here's one from Amanda. It says, do you have a best recommendation for mounting? What seems to give the best results? And we talk a little more about considerations for wall mounting and floor mounting. So some of the standards that we see, you can't mount the enclosure directly to the wall. You have to have 2 inches minimum between the wall and the enclosure. And so we do have mounting, and I'll show you those. I'm going to go back to it real quick to our accessories. And we do have accessories that are used for mounting. So you can see the picture here on the right. This is designed to seal on the enclosure with the blue gasket and also a blue gasket to the wall or the surface you're mounting to it. It gives you a 2-inch space, and this enables you to clean behind that control enclosure, flush behind it, inspect behind it, so you don't get anything trapped between the wall and trapped between that enclosure. Also, you want to mount, like we talked about, off the floor. Okay, so you want a minimum of 4 inches between the enclosure bottom and the floor. The more space you could put underneath there, the better, so you could flush it out and inspect it much easier. Okay. All right. What's the next one here? Okay, the one here from Jeff. What about enclosures in Zone 2 that don't come in contact with the food? What is required there? So typically, where food doesn't come in contact with enclosures, we see requirements that are typically stainless steel, or there may be requirements for NEMA 4X as well, because there might not be in the washdown zone, but there may be some cleaning involved, maybe once a week, or wiping down. So there might be some requirements for a NEMA 4X. Is what we typically see where it's not coming into contact with the food, because it may be adjacent to other zones that are getting washed down every day, so there may be high humidity in the facility, so there may be those requirements where you may have corrosion issues, and so you're going to want to use a stainless steel enclosure. Why are there no mounting holes in the Rittal Hygienic Design compact enclosures? We understand that some of the OEMs and machine builders will support the enclosures on a frame on the machine. They may support it from the bottom, and so they don't need the mounting holes. So this just eliminates the need to have to plug up any unused holes. So our theory is the less holes we put in it, the better. That way there's no additional points to plug up or where the water or bacteria could grow, because we recognize the need where folks sometimes even 50% of the time don't use those mounting holes. Okay. All right, so here's a question from Juan. How do you assume the clean if you have either a clean in place or clean out of place? So clean in place typically it's not really involved with the enclosures. That's typically, inside the pipes in the mixing chambers and things that you're trying to clean out on the inside. We're not trying to clean inside the enclosures, so it's typically the same requirements for that equipment. There's really not anything different required for that equipment. Clean out of place, so if you're taking your equipment apart and cleaning it, that's different. Our enclosures lends itself to easy cleaning, where if you need, you don't really have to disassemble the enclosure. You don't got to open the door to clean it, so it lends itself to those easier cleaning in those applications. I have condensation in my panels after washdown, because we need to keep it cool in the meat production, and I'm using hot water to clean. Okay, and so they're getting condensation inside the panels. So that's that's a pretty common thing. You know, you've got a cold temperature inside the production room, and it could be 34 degrees. And we're also, so it's cool inside that enclosure, and then we hit it with hot water that creates the condensation inside. So I have stories where guys will open up a panel and water comes running out. In those extreme cases, more than likely they have a small gap in their gasket where the gaskets are separated. All you need is a pinhole. If you come up there with high pressure water, you're going to drive water into that enclosure, and it's going to create what looks like, you know, a lot of water in the bottom of the panel. You're not going to fill up an enclosure with just condensation. To solve some of the condensation problems, we recommend that you could actually put a small heater in the enclosure. And what you could do is have that heater turned on by your PLC or other controls to turn that heater on to bring the temperature up in that enclosure right before you wash down. And what that will do is reduce the condensation, and then you could have that PLC turn off that heater after the wash down process. So that's just another way where you could eliminate your condensation or reduce the amount of condensation that you have. Okay. Polyurethane seals on my enclosure door start to deteriorate and leak water over time. Does this happen to the blue gasket on hygienic design enclosures? So what we've seen in a couple of the pictures I showed you, yes, they start to deteriorate and they leak, and they're very difficult to replace. So we don't have any issues like that with our blue silicone gasket. The blue silicone gasket is very thick, and most of the gasket is actually protected behind the flange of the door. So very little of that gasket is actually protruding from that enclosure. So most of it is very well protected behind the door of the enclosure. So you could see, like in this picture, a lot of it is actually behind and not exposed. And the other thing is that water, it's a non-porous, non-absorbent silicone blue rubber gasket. And so nothing, you know, water comes right off of it. It's smooth and nothing's going to grow on it. So we don't have any issues that we know of. It's been over 10 years that this product's been on the market. And like I said earlier, if you have to replace a gasket, it's typically due to some mechanical damage or, you know, human error. They banged into the gasket and ripped it or something like that. So it's not, we don't hear of any problems due to washdown where the gasket has come apart. So very durable, and it'll last the life of that enclosure. Okay, got some more questions here. Here's a question from John Sebastian. Does IP69K testing automatically give you IP67 and IP68? No, those are actually different tests. The 69K is for high pressure, high temperature, wash down, hose directed high pressure, as where those other ones are submersion for various lengths of time, various depths, where you actually put the enclosure or the component being tested underwater. 69 isn't actually underwater. It's high pressure, high temperature jets, okay, which is stuff that you will experience in a food production facility where there's washdown. Here's a question from Bill. Can you use Teflon or Lexan for gasketing? Well, right now we're using the silicone rubber gasketing, but if that is something that you think is required for the food and beverage market, that's something that I could take on and investigate. And you could, feel free to contact me, and I'd like to talk to you more about that. It's not something we have now, but like I said, it's silicone rubber. But if there's needs or requirements that would require something like Teflon or Lexan, I'd like to hear from you, Bill, if you want to contact me about that. Okay. Let's see. Okay, got just a couple more minutes here. And just so you know, if I don't get to all the questions, that you will get a Q&A transcript later on. We're going to send out a link to the on-demand version of the presentation, where you also have get the Q&A transcript, and also you'll be able to access a PDF of this PowerPoint presentation. Okay, so it's a question from Steve. Are 316 stainless steel hygienic enclosures available? Well, right now we only have 304 as a standard product, but it's possible to make 316 stainless steel enclosures. That would be a non-standard, but it's in our capabilities. I would recommend contact our local sales man in Rittal and discuss that with them, or you feel free to contact me and we could talk about what your situation is and your need for the 316 stainless steel. We do find that 304 stainless steel is more than adequate for our food and beverage applications. For wash down requirements, they resist caustic chemicals that are used in the cleaning process and in also the sanitation process. So, but we'd like to talk to you more about that opportunity and your need. So, like I was saying, I'm located in the Schaumburg facility near Chicago. We have 3 food and beverage account managers that are 3 of our sales reps that are dedicated just to the food and beverage industry. So we're dedicated to serving the needs of the food and beverage industry. And we have, like I said, 3 guys that are dedicated to this industry and to help promote our solutions and to help out customers in the industry. So we do have resources to help you, to consult with, and to answer all your questions and as far as product selection and requirements in the food and beverage applications. Okay, let's see. Got 2 more minutes. Here's a question. I like the design of your hygienic design enclosures, but if you don't have the sizes I'm looking for, will you make my size? Well, we can't make every size, but we certainly would be interested in talking to you if you have a need for various sizes that we could talk about it. So I would encourage you to contact your local Rittal Corporation account manager and talk to him about the opportunities that you might have. But we can do special sizes. We have new sizes coming out every year, so check back with us. We may have your size at a later date. So I've run out of time. That's all the time we have. I want to thank everybody for attending my webinar today. I really appreciate your time. I want to thank IEEE Global Spec for hosting this and organizing this for us. I appreciate that. So again, thank you for your time today. This is John Carnevale with Rittal Corporation signing off. Thank you.